Hello everyone. This is a short tutorial on how to use the expressions and pairwise heat map generating functions within the Heatmapper interface. Heatmapper is the free online application for visualizing different types of data as heat maps. It's the first tool of its kind that allows users to display many different classes of heat maps in one user-friendly web application. Heatmapper has 5 different classes of heat maps: expressions, pairwise comparisons, image overlap, geomaps, and geocoordinate heat maps. This tutorial only deals with the first two, expressions heat maps and pairwise heat maps. The expressions function allows users to view unclustered expression data. This could be transcriptomic data from a microarray or RNA sequence, or data from a proteomic and metabolomic experiment. The pairwise comparison function displays pairwise distance heat maps or matrices and pairwise correlation heat maps. Before we delve further into these heat mappers, let's take a look at how to get to the Heatmapper interface. To get to the Heatmapper homepage, simply open up your favorite browser and type in heatmapper.ca. Here you can see all the heatmappers listed out. Let's learn about the inputs of the expressions and pairwise comparison heatmappers. Expressions heatmapper takes in comma-separated files, tab-delimited files, and Excel files. The pairwise comparison heatmapper takes in all of these and PDB files as well. Let's take a look at the expressions heatmapper interface first. The gray bar at the top lists the different types of heatmappers. The ribbon on the left showcases the different options available for the heatmapper, and the tabs across the top of that show the different viewing options. Both of the heatmappers discussed in this video allow the user to upload multiple files as well as a single file to view heatmaps. Let's go through an example file to explore the options in the expressions heatmapper. Here I have a test file that has rows and columns labeled with the English alphabet and is populated with random numbers from 1 to 100. These numbers have been generated with the random function in Excel. Expressions heatmapper allows scaling by both rows and columns. This allows the user to view both row and column dendrograms from the bar at the top. It allows the user to select both brightness of the plot and the number of shades that are being used, and to select a custom color scheme. Next, let's take a look at the clustering methods in expressions. There are 5 clustering methods available in the expressions heatmapper. These can be used for computing hierarchical clustering. The average linkage option means that the distance between the two clusters will be the mean distance between all objects of the clusters. This is the default option. Centroid linkage means that the distance between the two clusters is the distance between their centroid values. Complete linkage means that the distance between the two clusters is the largest distance between the objects of the clusters. Single linkage means that the distance between the two clusters is the smallest distance between an object of one cluster and another object of another cluster. You can also import existing clusters. This allows the user to upload existing clusters from a file in the Newick tree format. In this case, the node names in the tree have to match the label names in the data file and must not include blanks, colons, semicolons, parentheses, or square brackets. If none of the options are selected, no clustering will be applied to the data, and the row and column dendrograms will not be created. The distance measurement options will no longer be applicable either. In all other cases, however, there are several distance measurement methods available. Of these 5 options, the Euclidean option means that the distance is computed as the length of the line segment connecting two values. Pearson's means that the distance is the absolute value of the Pearson correlation coefficient between 0 and 1. In the Kendall's tau method, the distance is the number of pairwise disagreements between the two groups of values. This means that the larger the distance, the more dissimilar the two clusters are. And in the Spearman rank correlation, the distance is measured as the strength of association between two ranked values and groups. Finally, the Manhattan option means that the distance is the sum of distances along each dimension between the two values. Remember to apply the clustering to both rows and columns in order to see both dendrograms. At this point, you can download your file as either an image or a text file, or view advanced options to give your plot a title, axes, labels, or define the resolution of your image. Let's explore the options in the pairwise comparison heatmapper through another example image. The pairwise comparison heatmapper allows the user to choose the type of matrix to calculate. There are 3 matrix options that can be used. With the distance matrix, the default option, each row is treated as a point. and Euclidean distances between the points are calculated. With the correlation matrix, correlations between the variables in each data column are calculated. The display data as is option means that there will be no matrix applied to the data and the values will be directly mapped onto the plot. The distance measurement options available here are the same as those in the expressions Heatmapper. A bit further down, the pairwise comparison function allows the user to reverse the data and set the aspect ratio before downloading the plot as an image or text file, just as in the expressions Heatmapper.